Well, hi, all you scouts.
Good evening.
Is that your boss, Dad?
No.
It's going to take me a little while to get
I think Devin's
how everything works inside of Zoom. You guys are probably all better experts at this by now than I am. So we're going to give it another maybe a minute or two here. Let some other people jump on, and
Hello, David.
Reed, you need
feel
to
free to chat around if
This
there's
is
you know.
body 127. I know, that's what I named you. Oh. Are you muted? No way.
What's your name?
Oh, Boy Scout. I'm a Boy Scout.
I got a Boy Scout.
Oh, Cub Scout. Okay, then I gotta change that.
Soon to be. You'll be a Boy Scout before you know it.
Heaven. Oh my God, it's so difficult. You got to type. You type like grandpa.
I do. I'm happy. Devin in the meeting.
I'm going to see if I can roam around here a little bit.
Who's Devin? Devin disappears out of nowhere.
How many do we have from Pack 443? Is it just you, Evan?
I think so. Pop.
So for right now, you're probably not, you're not even concerned with what the school looks like. Our school where we normally meet is completely covered by dandelions right now. It's just a big old sea of yellow.
It's good for the bees.
It's good for bees, that's right.
What is it?
They said the playground yard is all.
So, all right, I think I got a couple more I have to admit here.
Spanish Barometric.
Yeah.
All right, so the first thing I wanted to do was show off what I'm calling my isolation uniform here. I got my hat. I've got my neckerchief. Supporting all of the uniform until you get to my shorts. I don't think plaid shorts are part of the uniform. All right, well, this might be about all we're going to see here. We're going to go ahead and get started. So,
Let's just concentrate on.
did you guys have a good time doing the experiments?
Ours is still going.
I need to unmute everybody again. Well, a lot of people are still muted themselves. So,
Right there.
experiments? Oh, you got yours in the window. Very cool.
We don't have a great window that always faces the sun, and then it's got a little shade from the tree, so it did okay.
You did okay. Well, mine's in the sun most of the day, but I was expecting to see a little bit more, but it was all right. I'm going to remind everybody, if you're muted, go ahead and take your mute off here. I'm going to try letting us all talk here a little bit for a few minutes, and then when it gets too crazy, I'll push the silence button. Silence. So, ask again, did everybody have a good time doing the experiments?
Yeah. Yeah.
What was the coolest part? Nothing?
The condensation where like the little raindrops.
Oh, just seeing it actually
See you.
condensate up there. And then,
I mean, is it hot?
cool. Michael, that's a very STEM background you got there. Good pick.
You pour it into this barrel.
Okay.
Guys, doing a
I'm
video.
going to see here if I can
Do
show my screen. We're going to go through a quick little PowerPoint here.
What are you doing? You can't go on that.
All right.
You don't have the details. They got emailed to me. I do not have them that I can give to you.
Just tell me what they are then.
Here, I'm gonna shut this
Tell
out.
me the password in the.
Hey, Tucker. You're a cute puppy. Yes, you are. You are cute. Hey, dog.
Okay. All right, so are you guys able to see my screen or not?
Yeah, we can see it.
Yes, I made.
All right, so we have the water cycle. Then
Okay.
this is our first one. I want to make sure, hopefully it's going to keep showing me if people are trying to get in. I didn't quite get my picture of the water cycle, so I'm going to switch over to that real quick.
She gets back.
So I'm sure you guys have all seen pictures like this before, where you've got a body of water, whether it be an ocean or a lake or even just a small pond, and that water there is evaporating. It goes up into the air, and then you get the clouds, and the clouds, they condensate. There's condensation, and then that creates precipitation, which brings it back down to our reservoir. That's exactly what we were doing within our bag. But now there's some other areas that, you know, we didn't really talk about as much. I mentioned it in the video, but there's transpiration where plants actually are even, there's water that's being essentially evaporated out of plants that also goes in to add to the rest of the water cycle. So, and then there's also, once you have your precipitation, you have runoff from snow or rain that goes into certain bodies of water, lakes, streams, and such, and then that actually can go into the ground, get filtered. It goes into your groundwater. It can go into other bodies of water like lakes and such. So there's really a lot that goes on in the water cycle, and we were just looking at one small part of that. All right, so that brings us to the first experiment, which was the Ziploc water cycle. Let me just really quickly, I got to make sure that I've got everybody in here.
Can I go outside since Tucker's no longer out there?
Okay, I think we're good.
I thought you sent him out. I thought you sent.
Okay, so in our experiment, do that. In our experiment, we did the Ziploc water cycle. We took bags out, we made a little picture on them, added some water and food coloring, put that into the bag, sealed it up, and put it in a window. And basically, the sun did the rest for us. The sun helped to evaporate the water that was at the bottom, came up to the top of the bag, it evaporated. And if you take your finger and run it along the top there, then it was pretty easy to see, you know, a lot of dribbles come down that bag. So a few questions that I have for you guys. What does the water at the bottom of the bag represent? Just go ahead and shout it out because I can't really see everybody anyway.
Ocean.
Lakes.
Ocean. Lakes, streams, rivers,
Bodies of
any body of water.
Okay.
Lake.
And
Oceans.
that's all correct. Good job, guys. What is the steam in the bag? You see that? Again, go ahead and shout it out because I can't see everybody.
Me?
Anybody?
Oh, precipitation.
I didn't quite catch it. It cut off a little bit.
Precipitation. I can't say it.
Actually, the
Condensation.
steam is, well, at the top when it all collects, that would be your condensation there. I'd say the
If the
steam
computer
is
faces the light, it doesn't make
evaporated
a noise.
water. That's that evaporation process of it warming up and going up to the top of the bag. And then when you know that the bigger pooled amount at the top there, that's your condensation. And then especially what happened in the evening with your bag?
We're still gonna need that hot water.
Did anybody notice that it was a little bit different throughout the day, what it was doing? No? So I was noticing that during the, like in the afternoon, I'd get a lot more steam, but then when it cooled down, especially in the evenings or early morning, that's when I would see a lot more of the little droplets start running down the bag.
Yeah, that happened to me, bro.
That happened to you as well? Okay, so
Yeah.
the cooling effect of it being cooler in the house, or you know, the sun not beating on it, causes that condensation. That water cools back down, then it starts dribbling down. And what's the dribbling down? What's the droplets falling on the side of the bag?
Rain.
That's your rain, your precipitation.
I have a really bad sunburn. My arm right here.
I see that.
Yeah, outside too long.
Gotta use sunscreen, my man. Okay, so the second experiment, cloud in the jar. Did you guys have fun doing that one? Did everyone do that one?
I had to use a pickle jar.
You used a pickle jar too? Perfect.
I had to wash it out.
I've got my mason jar and my pickle jar.
3, I think.
All right, so did it smell like pickles?
We washed all of it out, I'm pretty sure.
I've washed mine in the dishwasher like 5
Although it-
times and it still smells
Although
like
we're pretty much creating the things for a tornado to happen.
That's what my son said as well. The thing is, it's not, we're
You
not
can't really
talking
create a
about-
tornado in that size.
We're not talking about, you know, the warm and the cool air currents causing more of a tornado action. This is simply, this is really kind of the same thing as what's happening in your bag. It's just at a more rapid pace. And why is that? Why is it happening faster?
I actually don't know.
Okay, well, it's because we've got ice on the top there. So just for anybody who didn't do the experiment, feel free to give it a shot after this. But so we added some hot water to an empty jar. And this was actually, in mine anyway, I stuck it in the microwave and I let it run until it was at a boiling point. And then we added some hairspray, and I did both ways. I did the hairspray and I also did the match. And I'm going to ask you guys about that here in a minute. Placed a lid on the jar, covered the lid with ice, and then just watched to see what was happening. Now, who used hairspray? Did anybody use hairspray?
I used the match.
Okay, so most of you, it sounds like might have used the match. I actually had better results with the match every time. So that, and essentially what you're doing is you're trying to get those water molecules to stick together. And here's the thing that I don't know. I was going to do some more research, and we're going to talk about things that you should keep researching and looking at. But we actually, I think that the molecules binding together might have something to do with ozone, and that's why the match works better. And I think that if you had an aerosol hairspray, it might work better. But we don't really use a lot of aerosol hairsprays anymore. Most of them are pumps nowadays because the aerosol was not good for the environment. So that would be something that you could look into yourself after the fact. All right, and so did all you guys get clouds, or did some of you not?
We didn't.
Who didn't?
I got clouds. Sorry about all the birds making noise.
Oh, that's okay. So raise your hand if you didn't get a cloud. Okay, I see you, Evan, there. You didn't get one?
No.
Okay. All right, well, now did you all, so people that you tried the match also did not get a cloud?
We need to do that. Yeah, just tell them we didn't do that.
Okay. All right, so give it a shot again with the match. I think for me it seemed to work better every time using the match. Have your parents help you with the match, please. Okay? And I actually let my Weevilo give it a shot with the match, and he had a burn in less than 2 seconds. I don't even know how he managed that. But so have your parents help with the match. Okay.
I thought the
I'm
birds.
going to go back to sharing here. Okay, so a few more questions here. What's happening inside of the cloud? We kind of already covered this, but what's going on inside the jar? Anybody?
It's clouding up.
Okay, it's clouding up. What's causing the cloud?
It's definitely clouding up a lot.
Makes it misty.
Okay, we got steam. What's the steam going back to the bag? What was the steam? Evaporation. All right, so we had, just like in the bag, we had evaporation going on. Now it was from an outside force. It was because you heated up the water somewhere else, okay? But then you also had the ice on top of the jar. And what was the ice doing? You guys remember that word? Condensation. Okay, so yeah, the water was evaporating because you had it hot water, or it was at a boil. And then you, I see somebody in the chat here. I don't know how to work the chat yet, though. There we go.
Wait. I know what the ice represents.
Okay.
High up, like high up. Because the higher you go, the thinner the air gets, and the thinner the air gets, the colder it gets. That's why space is so cold, because there's no air in space. That's why it's freezing in space.
Bam! There's a correct answer right there. Good job. That was Jackson, right?
Yep.
All right. So yeah, your ice on the top of the jar is the same thing as our atmosphere. It might be nice and warm, especially this week. I mean, today was a little bit cooler, but for the most part, it's been really warm here down on the ground. But you go even a few hundred feet, a few thousand feet up into the air, and it gets cool. So that's definitely what that ice is representing, is all the cold air that's up there that helps with the condensation and condenses that evaporated moisture into rain droplets. Okay, now I already talked about this. Why did we add the hairspray or the match smoke? To help the molecules what? It helped the water molecules bind together so that we could see them a little bit better. I mean, there was still always going to be, there was always evaporated water in there, but the smoke or the hairspray just helps it so that you can see it. All right, so I've got some big words for you here. This is something that you can keep on learning about the water cycle and evaporation and how things work So, and I already mentioned this one a little bit. What is evapotranspiration?
Can we try to do the cool thing?
Maybe.
That was water evaporating from
Does it
what?
mean like evaporate and transport, like transportation?
No, that's a good guess. But it was actually from, that's water that has evaporated from the plant. Oh, I saw a hand, but Mary said it. So that was water that evaporates from outside, out of the plants. So water, plants are taking in water, right?
I'm outside.
You guys done any gardening? You got to water your plants, but they die. So they actually hold a lot of moisture in them. And here in Nevada, you see all the green grass and weeds that grow around the state. Well, what happens to all that green grass and weeds by the end of the year, by the end of summer? You guys know?
They die.
They die. They turn brown and they die. They dry out.
Ice cream.
So
Yeah,
that's
boy.
because that water has all been sucked out of those plants by the sun and the heat during the summertime. And that just adds extra water to the water cycle, extra evaporated moisture. What about your lawn? Do you think your lawn is affected by evapotranspiration?
Yeah.
Yard.
Yeah. Have you ever got a brown spot in your lawn that wasn't caused by the dogs or the rabbits? In the summertime, it's easy to have parts of your lawn dry out. They're not getting if it's not getting enough water. All right. So, you guys know what barometric pressure is?
Pay attention.
Okay, so barometric pressure is the pressure from the atmosphere on us. And it goes higher and lower depending on what's going on in the as far as if we have a high pressure system moving in or a low pressure. Have you ever heard the weatherman talk about you know, there's a high pressure ridge or there's a low pressure coming our way? Well, that all changes how our environment works. It changes how this water cycle works. It makes it, if you have a low pressure system that comes in, you might be a lot more likely to have rain.
My mom.
So barometric pressure can actually change what's happening in these bags. You might end up seeing more condensation or more droplets start coming down if we're going to end up having a rain, you know, if we're going to be getting rain actually because the barometric pressure is low. Keep in mind things like that as well. And do a little research if there's any part of that that you think might affect what's going on in your bag or your jar. All right, let me see what the next question was. How might barometric pressure, I got stuff in my way here, change what is going on in the bag? Oh, I just gave that one to you. And then the final one, what other components are there to the water cycle that we're not addressing here? What's going on? What is there that I talked about? And I'll bring back up the picture of the, let's see. Here's our water cycle picture. Oops. Jeez. Way too many buttons when you're running this. All right. Oh, what else is in this picture here that you see that we didn't have going on in our bag? Did we have evaporation?
Yep.
Did we have condensation?
Yep.
Did we have precipitation?
Yep.
Now, did we have infiltration?
No.
No. So infiltration is water from ponds and lakes and such going into the ground and getting filtered. Did we have plant uptake? Nope. We didn't have transpiration. But here's another good, I'll post another experiment on our website that'll show you what transpiration can do. Because you can actually, if you ever get stranded somewhere without fresh water, you can actually make your own fresh water that you can drink from plant life. If there's a bunch of grass or weeds. In fact, I did this in our pack. We have a survival night once a year. We talk about different survival tactics that you can do if you're ever stranded without things like food or water. And I made it was probably about a gallon of water that I made just off the weeds that I pulled in my backyard. And you just put a piece of plastic over the top of a container holding your vegetation, and then you put something in the middle of that plastic so that when it transpires, it collects on the top of the plastic and then drips back down into your container that holds the water. Yes, Evan.
Sorry.
Evan,
Oh yeah, sorry. On the mountain sublimation, that's a new one we didn't go over.
correct. Yeah, there's another one. That's one we didn't do. Now, so I actually work for the water master's office, and what we do is we monitor all the reservoirs around the area, and we see how much water is going to end up in the Truckee River and the Carson River, and all that water eventually ends up either at Lahontan or at Pyramid Lake. But every year, we're watching what happens with how much snow we get, how fast it runs off, how much of that's going to go into the ground, how much is going to be carried down the river, and we also have to monitor how much is evaporating. And people that store the water, whether that be Tumwa, who gets us our water into our houses, or the Pyramid Lake Paiute tribe, or the farmers out in Fallon, they all actually, depending on how much water they keep in their reservoirs, they actually get charged for their water that evaporates on the different reservoirs, if they end up leaving it in there, because it's, if they leave it up higher, they'll actually have less evaporation than if they were to let it go down to Lahontan or Pyramid, because it's a lot warmer at those two spots than it is up at like Boca or Stampede or Lake Tahoe. So that's something else to think about is how much is evaporating off of these bodies of water. The other thing that, especially if you live out here at Spanish Springs, you can actually see some pretty cool weather happen now and then. If it stays pretty warm late into the winter and then it cools down real fast, like if we go from having 70-degree weather down to where we have near freezing weather, you'll actually see huge storms come over Spanish Springs coming from Pyramid Lake, and that's called a lake effect storm. And those actually seem to drop the most amount of water over here in Spanish Springs as far as snow or rain. Yes, Jackson.
I have a question. Does Greenland actually have 300 days of rain a year?
I don't know that one, but I'm sure Google does. Ask Google. Google knows it all. Thanks for the question, though. All right, does anybody else have any questions? I'm going to switch this back so I can see all of you. I see a bunch of heads shaking no. Nobody has any questions? You learned it all? You ready for your test?
No.
No test. No test.
No
please.
test?
No.
I hate tests. I hate them.
I had somebody sitting here.
I also hate distance learning. I hate it even more.
Well, yeah, distance learning is kind of been a bummer for sure. Hi, Courtney. I'm sorry it took so long to get you in there. I didn't see it until just now, but
Microsoft Teams is horrible now.
Yeah, Microsoft makes some interesting stuff. Sometimes it works great, sometimes not so much. Okay, so nobody had any other questions?
Yeah.
All right. Well, I'm going to stick around here, and if you guys do have any other questions, feel free to ask me. Otherwise, you guys can chat amongst yourselves, or if you're
Any other
ready to
questions?
go to bed, or I'm sure you're not going to go to bed yet.
Thanks for letting me stay.
Oh, you bet.
Hey, he said I could.
Bye.
Bye. So are any of you from